Today, we'll dive into why building reliable text-to-SQL agents is tough in real-world settings and how our semantic agents can make it manageable and accurate. Businesses today want to add natural language interfaces to their applications, allowing their users to ask questions of their real-time operational data. Imagine being able to simply ask an inventory app, which products need restocking, or which customers purchased more than $1,000 last month. The problem is that it's difficult to create such an app that responds reliably. Hallucinations and inaccurate replies, common with generative AI, are unacceptable in business use cases that rely on factual information. Solving that problem requires stitching together multiple components, such as vector DBs, LLMs, and frameworks such as LangChain, managing RAG pipelines, and extracting all the relevant context from the database. That gets very complicated very fast. Also, moving data out of your system of record, the operational database, adds security and governance risk and creates data consistency problems. This is where SkyAI Agents come in. These no-code semi-autonomous agents make it easy to extract the right database context, handling all of the complex work to ensure accurate answers without hallucinations. While the agents automatically infer context from the database, some knowledge naturally resides only with experts. The platform enables these users to review and refine the inferred context for greater precision. To illustrate this, let's look at a simple example: IMDb. Imagine a database filled with movies, actors, directors, genres, and ratings. Let's say we want users to ask questions like, find the highest-rated movie starring Clint Eastwood from the 80s, or list all directors who directed more than 10 comedies between 1990 and 2000. Answering these questions involves complex queries, drawing from multiple parts of a highly interconnected schema and interpreting semantics, like understanding 80s as the years 1980 to 1989. Now let's go through the process of creating the agent, tuning, and deploying it. The first step is to ensure you have defined the data source you want to use. Next, let's define our agent's intent. We give a clear description of what this agent is meant to handle. Our no-code system provides guidelines, helping you create a precise description so the agent's purpose is well defined from the start. This description guides the agent making accurate decisions when selecting tables. You can add guardrails as well, for instance, adding rules or identifying things that are out of scope. Once the agent selects the relevant tables, it generates a simple description and context for each one. If the selection isn't quite right, you can easily modify it. Then the agent prunes columns that aren't essential. This helps in two key ways. It reduces the amount of data processed, minimizing LLM token usage, and it keeps the agent focused on the data that matters. Again, the expert user can easily modify the agent's work. After selecting columns, the agent identifies categorical data, columns with values like genres or labels used to group or classify data. For example, a genre column might include categories like comedy or horror. For these, we automatically create vector indexes, enabling semantic searches like cowboy movies to find entries with genres such as Western. With the structure in place, it's time to test and refine the setup. Start by running sample queries and observing the results. When you identify a prompt and its corresponding SQL query that yields the desired result, you can designate it as a golden SQL. These serve as benchmarks, defining what correct responses should look like. Golden SQL helps guide the agent to generate accurate results for similar prompts in the future. If needed, adjust the table or column context to improve accuracy, iteratively training the agent until it produces satisfactory results. Once that's done, you can deploy the agent, making it available to apps to consume using a simple REST API. Now, the agent is trained and ready for real-world use. Let's look at how it performs in a conversational app for IMDb. Let's try a straightforward example. Find the highest-rated movies of all time. Here the agent locates the ratings table, orders results, and returns the top entries accurately. Now, let's increase the complexity. Find the top 10 actors who played a pirate, ranked by the number of movies they starred in as pirates. The agent pulls from multiple tables, uses semantic search to locate pirate as a character archetype, and accurately generates the where clause. Behind the scenes, SkySQL handles the heavy lifting, managing RAG pipelines, vector indexing, search, and LLM communication. It includes guardrails, for example, ensuring generated queries never modify the database or limiting the amount of data retrieved. This demo used a simple database for illustration, but the true strength of the product lies in handling real-world complex enterprise databases with hundreds of tables, columns, and intricate data relationships. We're also building an online evaluator to score each response for confidence and accuracy. It relies on the provided golden SQL examples and context to ensure reliability. The evaluator is designed to assign lower confidence for uncertain responses rather than risk assigning high confidence to incorrect ones. This approach ensures trustworthy results. SkySQL AI agents make it easy to build natural language interfaces that are accurate and reliable. By handling the complexity behind the scenes, they let businesses create smarter, more intuitive apps that turn data into real value quickly and securely. Go to .skyschool.com and give it a try.